Dear all, welcome to Civil Services with ZAKI. Today we are going to discuss about one of the most difficult concept in the geography, and it is Coriolis effect. So see, what is the Coriolis effect? And basically it is related to the major geographical concept series of our video. So if you are new, then you must subscribe our channel for these type of videos, because we provide you a visual like this type of the animation and all that. Basically it is very significant to understand any difficult concept in geography or other scientific subject. So let's we move forward and see what is the Coriolis effect. So what is the Coriolis effect? So as you know, as we discussed about the pressure gradient force in our previous video, air drives airflow in the atmosphere due to the pressure gradient force. But wind do not blow exactly the direction we would predict. So if we would predict here high pressure, here low pressure, wind flow from high pressure to low pressure, but not as you see here is even directly. If we only consider pressure gradient, we assume that it flow that directly, but it is not at the natural condition of the atmospheric circulation. So all object, so if we see the all object, whether it is air mass, we also provide you a video on the air mass, what is air mass, what is cold air mass, warm air mass, etc. So another is it's also in fact air mass, ocean water or aeroplane or any moving object across the surface of the earth display an apparent deflection. So if you see here high pressure, here low pressure, it don't go directly, they deflect like this or this. It means why this object in deflected, because this deflection is due to the Coriolis force. So this is the Coriolis force. So that's why the object deflect due to the Coriolis force. So let's understand Coriolis force step by step. So why does this apparent deflection occur? So as we discussed the apparent deflection due to the Coriolis force. So why does this apparent deflection occur? So see here, it is our earth. As you know, our earth is not spherical, it is bulged near the equator. So if you see here our earth, so our earth rotate in 124 hours. So the easiest way to understand the rotating wind north or south, so understand is by considering air that is moving north or south to the equator. So earth atmosphere including any moving air is carried around the earth by rotation. So why this type of the cloud and carried around the globe? Due to the rotation of the earth. So rotation of the earth played an important role in this circulation. So see here one by one. So if we see here this blue arrow, so the blue arrow shows how much distance the surface rotates in an hour. So if we see here, this surface rotate this type of area in 1 hour. Equator, near equator more, near pole is less, and at the pole it's 0. So the arrow longer near the equator, as you see, longer and shorter towards the pole. So and these area have to travel. So relatively long distance these area to travels, and therefore faster velocity. So area distance, more area due to so more area means more speed, more faster. So distance travel and the linear velocity gradually decreases toward the pole. So here more velocity, here less velocity. So velocity decreases if you go towards the pole. So let's move forward and see what happened near the pole. So if you see here pole, as you know, our earth rotates west to east. So what happened? So see here, at the pole, the distance, travel, velocity are both zero. If you go to the direct pole, whether it is north pole or south pole, it is zero. So the surface has no sideways velocity due to the rotation. So in 24 hours, an area directly at the pole simply spin 360 degree. So if you see here, pole, north pole, or whether it is south pole, it is north pole or south pole. So some area like this area. So it is 360. So these area rotate in 24 hours. And further, if you go to the equator, so equator cover these area. So it means time is the same 24 hours. It means the speed of this area is more than the pole. So whereas an area at the equator would be moved approximately 40,000 kilometers. So as the circumference of the earth due to the 40. So in pole they cover only few kilometers and near the pole, and at the equator they cover 40,000 kilometers. It means the time is the same 24 hours. It means speed increases near the equator. So we move forward and see here. So if we see some air moving towards the north direction from the equator, so from the equator to the pole possesses eastward momentum and its head wind was closer to the equator. So if you go to the closer, they deflect eastward here. So it appears from the perspective of the earth's surface to the deflected right to the east. So it is deflected in the northern hemisphere, it is deflected at the right. So further, if we see another, the air or air mass coming from the pole towards the equator, they deflect westward. So see here, the opposite occur as air moves towards the equator and encounter area with the faster surface of the velocity. As you know, this area is faster and this area is slower. So they lag, air appears lag behind the deflecting. So they appear to the lag behind deflecting to the west as if it being left behind the earth rotation. So as earth rotate here fast and here, so that's why it deflect towards westward. So if you see here another same pattern happen near the southern hemisphere, but here it is right and here it is deflected to the left. So in the southern hemisphere, if you see the southern hemisphere, air moves towards the pole, travel from faster rotating area to slower one. So it is appear to be rotating faster than the surface, so it deflects left. So it deflects left in the southern hemisphere and right in the northern hemisphere due to Coriolis force. So if you want to clarify concept very clear, so as you know, animation is the best way to understand the phenomenon, any scientific phenomenon. So see here, as you see here, it is our Coriolis impact. See here, Coriolis effect. So what is Coriolis effect? Coriolis effect affected various weather phenomena. So if we assume a circle here and it consider here circle, as you know, here circle A and here circle B, and it is the point of the rotation of the any circle. So see here, so see here as the same place. So if they rotate, as you know, it is rotating. So circle A or circle B. So if we see the circle A, if something travel greater distance in a shorter moment of time, it must be going faster. So circle A going to the faster and circle B is the slower. So if we see here, it is slower. So see here, see here, see here. If we put on the circle towards the globe and assume it is North Pole and it is Northern Hemisphere, as you know, that rotate this type of the, and assume some people on the Greenland and some other people on the Brazil near the equator. Some people near the pole and another is near the equator. So see here. So it means they rotate fast. So the wind near the equator is faster than the pole. And deflect right towards the equator, and it is here it's deflect slightly westward. And if we assume these wind are moving faster, and so here see here. So if a low pressure belt near the northern hemisphere, then the air divert eastward and this air from westward. So it's create a cycle in the anti-clockwise direction. So see here, anti-clockwise direction, as you see the cyclone. So that's why a cyclone in the northern hemisphere rotate anti-clockwise. If you go to the southern hemisphere, it's like opposite. So it is left and it is it's considered the right and westward, and so it is rotating at clockwise. So if you go to the southern hemisphere, the storm rotate at clockwise. So clockwise and anti-clockwise. So as you know, this is the very important concept in the civil services examination, and various times civil services ask this type of the question in various comment. Not in even this topic is also important in the civil services, but if you see, this topic is also important for the other competitive examination. And this concept is very significant. So that's why you must subscribe our channel and tell your friend about our initiation. If you have any concept regarding the geography, ecology, environment, then you must comment in the comment box, and also you can contact me, as you know the number is given in by the in the below. So let's see some common important fact about the Coriolis effect. So see here some fact about the Coriolis effect. You must remember these facts. Due to these facts are very significant for the civil services examination and other competitive examination. So that's why you subscribe our channel. Number one, Coriolis force is a result of rotating spherical earth. So why Coriolis force? It is rotating spherical earth. Another thing is apparent deflection due to right in the northern hemisphere, left in the southern hemisphere. The Coriolis force always act at 90 degrees to the direction of the movement. They always act 90 degrees to the direction of the movement. Another is increases with the latitude. So latitude increases, Coriolis impact increases. The minimum value at the equator and maximum value at the pole. So if we see the where is the maximum Coriolis force exerted? At the pole. Minimum Coriolis force impacted at the equator. And another thing is directly proportional to the velocity of the wind. It means if the wind velocity increases, then Coriolis force affecting the wind also increases. So you must remember these facts. These facts are very, very significant. See, number one, right in the northern hemisphere and left in the southern hemisphere. Always act at 90 degree to the direction of the movement. Increases with increasing latitude and directly proportional to the velocity of the wind. That's why this topic is very, very significant, and you share this video to your friend so they can also benefited by this video. And also if you want any question regarding the civil services examination and any question regarding the concept in geography, ecology, environment. So that's all about the Coriolis impact and Coriolis force. So thanks for watching this video. Thanks a lot.